Oceanography and Environment, Higher Institution Center of Excellence in Marine Sciences, University of Malaysia. Good morning, sir. So welcome you. I welcome you on behalf of Mizoram University. So before we start our program, so let me highlight our distinguished speaker from for today. As I said, Dr. Bihara Satariana is associate professor from Institute of Oceanography and Environment uh, from Malaysia University. Although he is working in Malaysia University, but he obtained his PhD degree from India, from Andhra University in the year 2005. And his area of research interest is marine biology. Under that, he used to work on this mangrove ecosystem and application of remote sensing and GIS. And not only that, he has national and international collaboration with different countries, and he has several publications with a high impact factor, more than 40 international journals. And not only that, he had invited talk from several universities, national and international, and he also received a distinguished award from national, international as well. So today, sir, I hope we can have a good interaction on this technological advancement for application in forest exploration. So now, before we start, let me invite our Honorable Vice Chancellor. If you want to say something, then after that, we can start our session. So, okay, sir.
Hello. It is very happy that Satyanarayana has come here for delivering webinar to our students and other people. He is a very renowned scientist and very hardworking scientist. He spends a lot of time in mangrove forest ecology studies, and he has done a lot of work in that particular area. And incidentally, he was my direct student. I taught him in MSc Zoology when he is studying in our university. So it is a very proud moment that a student giving a webinar to our university to his teacher. It is very good, and I congratulate him for the same thing. And he is a renowned scientist, a very hardworking scientist. So I deem it a privilege that he be invited to our university. Thank you.
Okay, so now we can start, sir. So now the time is yours. So we can start our program.
Can I start by sharing screen, sir? Can I go with sharing screen?
Yes, sir.
Yeah.
Okay, Suras, oh, yeah.
Can you see my screen, sir?
Yes, yes.
Yes, yes.
Yes.
Thank you, Chairperson. Thank you, sir. Good morning, everyone. First of all, I would like to express my sincere gratitude to Honorable Vice Chancellor of Mizoram University, Professor Samsvara Garu, and for giving me this opportunity today to deliver some of my experiences in the forest research. Though I worked on mangroves, but it is a wide applicability in other forest types as well. So also I thank the technical team for making arrangements to support this talk via Zoom platform, and thank you one and all. And I try to complete my talk within the stipulated time given to me. Thank you so much. And just to introduce myself, sorry, my name has been troublesome for you all to pronounce so long. But you can call me Satyam. Satyam is a common name everybody calls me, so you can use my name Satyam. And I'm currently, I was introduced associate professor with the University of Malaysia, Terengganu. My research interests are wetland ecosystems, especially the mangrove ecosystems, and to study spatio-temporal dynamics and its conservation and management. I'm associated with this field of research, especially with the mangrove ecosystems from the last 23 years now. Uh, Also, it's a privilege for me to say a few words about my university in Malaysia, where Professor Samsivara sir has recently paid visit last year in September. Actually, UMT is, in short, University of Malaysia Terengganu, in short, is known as UMT. It is located on the east coast of peninsular Malaysia in Kuala Terengganu, and now it is known as Kuala Nerus. So, as you can see in the aerial photograph at the bottom that was taken a couple of years ago, the university is located facing the South China Sea. And our slogan is a version of discoveries for global sustainability. And also, we are trying our best to make the standards high to the world-class university levels. And yeah, as you saw a couple of years ago, the picture was taken aerial photograph, but this is the current situation. Due to escalating number of the students every year, we got to raise several high tall buildings, and now this is the campus. You can see an aerial view of the campus. We have a lot of departments and central labs and so on to facilitate the students, registrations and their study and research purposes. With the proximity close to the South China Sea, our majority of the research we target marine ecosystems. Is always it comes as a forefront field for our research. Indeed, you can see the logo of our university is nothing but a coral reef. And also, we do have our own research vessel called RV Discovery. In Malaysia, whole Malaysia, UMT is the only university having a research vessel to conduct scientific cruise in South China Sea. So, indeed, along with marine fields, there are several other disciplines as well, but marine is always forefront. That's where I belong to. When you look at the aerial view of my campus, yes, you come across several forest, different forest types. You can see a luxuriant growth of mangroves, and also you have a very good beech forest for casuarina and other species, and so on. In fact, Malaysia is one of the mega diverse nations in the world with nearly 22 million hectares of the vegetation covered. We have different forest kinds. And if upper mountain, lower mountain, upper dipterocarp, hill dipterocarp, lower dipterocarp, freshwater peat swamps, coastal vegetations, and then mangroves. Yes, in fact, since I'm a mangrove man, I like to say a word at least about the mangroves. So here in Malaysia, the mangroves contribute up to 2.8% of the total vegetative cover. In fact, Malaysia is one of the very few countries that still holding the vegetation at the 50 to 60% of the land cover. Really, it's a greenery. It's a very good greenery you can experience if you visit Malaysia. Yes. Also, I would like to take advantage of this presentation to introduce my association with our beloved Vice Chancellor, Professor Samsira Garu. As he mentioned, yes, I did my doctorate master study in Nagarjuna University in Guntur between 93 and 95. And then I left for my doctorate studies, and then I left India almost like 20 years ago. I met Sir again in 2019 September. It's almost like 25 years. It's a wonderful feeling, and I was fortunate enough to spend a couple of days with him in UMT. In fact, he's the visiting professor to the UMT currently. It's been a very nice meeting after 25 years. I'm pleased with that. So yes, I'm always grateful for the kind concern of Professor Samsirao sir towards me and my career. Okay, coming to the today's talk, I would like to touch upon remote sensing, uh, especially in relation to the unmanned aerial vehicles. That's what we call them as drones nowadays. And also, I would like to highlight one or two mobile apps which are free to download on your cell phones, and you can use it in the forestry applications when you go for ground inventories. So I would I believe that this kind of information is quite useful. Though I applied this kind of techniques for studying the mangroves, but it has a wide applicability that we can try on the rainforest and whatsoever the forest near Mizoram premises and so on. So yes, um, the structural complexity in the forest, the roots, trunks, associated flora, fauna, and so on, always makes the forest inventors to face a big difficulty to conduct the field surveys. For example, what you are seeing here is a mangrove forest with a lot of crop roots expanded on the ground. Under these conditions, very hard for anyone to conduct a survey in the forest. So I would expect similar conditions for the rainforest and other types of forest as well. Probably I don't have much experience with the other forest types, but definitely there might be so much difficulties to conduct the forest inventories. It's not an easy task. And sometimes even you have to climb 4 or 5 meters just to measure the diameter of a trunk. So especially in the case of mangroves, yes, because the crop roots can emerge from the trunk from 4 or 5 meters above, and we always take the diameter above the topmost crop roots. So that means we have to climb 4 or 5 meters a tree just to measure the diameter, that which will be later on related to the biomass estimations and carbon sequestrations and so on. So how hard it is. Even making a plot inside the forest is not an easy task. It's often challenging. Either it is a mangrove or non-mangrove. I believe the same. And coming to the profile diagrams, if you wanted to do profile of sediments and if you want to come up with the profiles of the vegetation, it is a hard sum actually. So it is forest research is not an easy task. You have to have a lot of patience and a lot of interest, enthusiasm, passion for the research, then definitely you will find. But however, difficulty is a difficulty that everyone has to face, either student or the professor, the same. So nowadays, yes, the remote sensing has become an handy tool for application in the forestry research. As you all know, nowadays, the remote sensing technology has become an indispensable tool for the forest inventories, or especially because of its time saving and effectiveness. Means we can save time, we can minimize the number of field surveys, minimize the number of plots inside the forest, and then we can extrapolate with the remote sensing data. That's how we can get benefit from the remote sensing data. So then that ultimately reduces the cost of work as well. So if you look at the remote sensing, there are two types of remote sensing data sensors are available. One is passive remote sensing and another one is active remote sensing. For the passive remote sensing sensors, they depend on the solar light for the reflection and the capture of the reflect from the objects from the ground, of the ground. But whereas active remote sensing, the sensors have their own source of energy to transmit and receive. That's where the radar data comes in for the active remote sensing part. Whereas for the passive remote sensing, you can get the optical remote sensing data. Anyway, the remote sensing itself can compensate the field works which are very difficult to carry out in the forest, any forest, especially in some areas even we don't have access, even maybe because of security reasons. So such kind of things, remote sensing playing a crucial role. So remote sensing, again, you can look into two types. One is space-borne remote sensing. Space-borne means the satellites which you send to the space and then you receive the data. And the receiver received data, you can categorize into different spatial resolution data. That means some images are spatial resolution very low, and some images, some sensors can deliver very high resolution. So the choosing of a data set, whether it is a low resolution is good enough or a high resolution is good enough, that is depends on the objective of your studies, objective of your research. So as per the research objective, we can choose the required resolution data set to go on with the research purpose. Now, airborne remote sensing. Airborne can remote sensing data you can obtain from the manned and unmanned carrier aircrafts. So earlier, we used to fly, helicopters used to fly over a certain areas to take the photographs. We call it as aerial photographs. Yeah, so even nowadays, that has become quite expensive for the governments and stopped. So now, in that place, the unmanned aerial aircrafts, that means the so-called drones, are taking the advantage, and they are giving fruitful results. If you look at the spatial resolution of the drone data or air photos, it can go for high to very high. Even 2 centimeters resolution on the ground, you can get the images. That means very fine resolution you can obtain from them. So you might be wondering, maybe the satellite data have is expensive. We have to buy from the agencies and so on. Indeed, not necessary. Some of the low to moderate resolution satellite data you can download for free. They are available. And the most interesting thing is, even we don't even dream of it, there were satellite images taken during 1960s. That's what by a satellite called Corona. And they are available from the United States Geological Survey website. The only thing is that satellite was panchromatic. Panchromatic means mostly black and white image, but it's still a good resolution, 1.8 meters resolution data. You can obtain it, and we have used it for China, and it yielded a very good result. But however, we have to look into other aspects, which I will cover in the forthcoming slides. The most difficulty everyone face in the satellite data uh, is the cloud cover. So most of the images, especially for the areas in tropical and subtropical regions, in the forests and so on, so there have a lot of cloud cover, which prevent you to freely apply your satellite data. So that is where a big limitation. So you have to wait. For example, I want today the date. It is possible to order the satellite date for today itself, but you are not sure whether you could get it cloud free or not. So that is always a constraint for it. So here I would like to show you some example. If I look for an area in India to look at the coastal area, so always I come across the clouds, and it's very difficult for me to apply these images for my analysis. Not only for my analysis, I think for anybody who was working on the vegetation inventories. Then coming to the aerial remote sensing, yes, it's not like satellite data. The aerial photographs are not really challenged by the cloud cover, because you can maintain the altitude of that particular flight. So if the clouds are above, you can fly below the clouds to take the pictures. That means you can follow the weather conditions. You can adjust the timings of your photo acquisitions as per the weather conditions. So that is a very good advantage, and you get a high resolution as well. So the resolution could go for the submeters to the centimeters level, which could be a good advantage for identification of the species and very fine objects on the ground. You would be able to delineate them quite easily and precisely. So coming, yes, our topic is mostly on drones. Yes, we have so many drones indeed, from sports, that means just for play for by children, to even security wise, country security protection drones are available. So they have been very small to very large drones are available, and also they have a wide range of access. I mean sensitivity, then very close to the mid-range of sensitivity. They have it range, and also the area with different aerial platforms. Some drones have a one fixed wing. Some have multi-rotors. That means rotor means motors, and some have single rotor and so on. And nowadays, you must have come across COVID has brought so many drones into pictures again. So some of the drones are used to deliver the medicines or the food and so on. So there are different abilities of the drones. So you can find so many drones made by different companies to deliver certain goods, or to deliver the images for the research purpose, or to deliver for monitoring, just for real time monitoring and so on. So you can choose the particular drone as per your choice of the work. And I just wanted to show you some models which are quite popular, but unfortunately they are made in China. Indeed, I trust this brand DJI, which I am using it currently, the one which at the bottom right corner, Phantom, that is the one I'm using it, and it's working very efficiently. So there are models, as I said, that can be chosen as per the targeted task of your research. This is the one we have taken over an island with the vegetation. Of course, that was a mangrove, but the clarity of that particular image would be able to reveal the species composition and distribution from one end to another end. That means water edge to the back mangrove or back forest. What is the vegetation occupying at the front margins? Then how the donation. You would be able to visually interpret the donation inside the forest. You can easily, indeed, visual perception is one of the ideal steps for remote sensing analysis as well. So here you can easily identify what species occupying what areas and what is. So such kind of donation aspect patterns in the donation of any forest. So donation is also shown by the animals. Probably you can mark the animals in this particular region. This is animal X is available in that particular region, animal Y is available. So that means you would be able to bring some donation patterns very clearly, superimpose on the drone images itself. That much clarity you can get. Like any other satellite data, the drone images also have different characteristics that would help you to identify different objects for your analysis, data analysis. For example, tonality. Tonality is nothing but the color of the image. Sometimes the vegetation represents one color, the barren land represents one color, water represents one color, and so on. The color changes. So tonality, texture, how smooth the object is, how rough the object is. So that kind of characteristics would be able to assess what could be that particular object, what could be that particular tree. So that kind of information you would be able to retrieve very easily with a very good high resolution data like drone images. And also you have structures, some structures you can see. For example, if you look at the third row image, you can see a circle with no tree vegetation inside. That was the gap formed by the lightning strike. So the lightning strike killed the trees in that particular place. So such kind of observations would be very useful, and then you can delineate that areas, and then look at the regeneration timings, how long it is taking for to get back to the normal vegetation, and so on. Such kind of analysis are quite useful. For this particular talk, I'm using an area, what we call it as a situ wetlands. It is located on the east coast, very close to my University Malaysia Terengganu. Actually, here we try to apply the drone and compare with the satellite data and see the advantages and limitations. That's what I would like to share with you today. So, for example, coming to the city wetlands, it is playing city wetlands any wetlands is quite crucial nowadays. We are destroying the wetlands everywhere, but indeed they support a unique flora and fauna, which you don't find them in normal conditions. So we really have to look into wetlands conservation and management. Mangroves is just one part of them. There are so many wetland types, coastal wetlands, inland wetlands, and so on. So we have to really take care of them and that particular flora and vegetation and such kind of things. So now the city wetlands in Terengganu, it is playing a very crucial role for the local people for their livelihoods. That means the people go to that particular place to collect the plants, that means bivalves, some animals living in the forest, to sell in the market. And they catch crabs, they get some plants, and they can use it for some medicinal purposes. So this is all income generating. So then we try to use that satellite. We have chosen the area particularly because of the importance given to that particular. And this area has been declared as a state park in 2018 as well. So what we try to do, we try to see, we took the satellite data, one satellite data called Plidas. It is a French satellite data. And then we fly the drone again, and we took this drone data as well. And we try to compare the both data sets in terms of its quality, efficiency, and accuracy. Quality is the resolution, which I mentioned. The higher resolution, the better separability of the features on the ground. So then quality-wise, how best? And quality is not only resolution. Resolution, again, you have different types of resolution. Spatial resolution, spectral resolution, radiometric resolution, temporal resolution. So how, which one is best between satellite and drone? Then efficiency, for example, how much area can you cover if you fly a drone? And how much big area you can get it as a aerial image? And how long you take to analyze that particular data set? And what is the difference between satellite data analysis and the drone data analysis? How much time it is consuming? And then finally, the accuracy, how accurate the results that you derive from the satellite data and that you derive from the drone data. That's what we try to do. And I wanted to show you that particular thing. So for this small set of talk, I have chosen very small area, which is about 12 hectares. Um, that has different features in the forest, including with the water bodies and so on. So then that's what I chosen for the today's presentation. Let us see how it looks like. Okay, though you are using satellite data or drone data, definitely you have to have some representative ground inventory. You don't have to do it so much extensive like you do normally without the satellite data, but you have to have some representative data sets collected on the ground for you to interpret the data. Satellite data is there, but it needs interpretation. The person who has ground knowledge can interpret the data better than the person who don't have the ground knowledge. That's why we have to go to ground at least for some places to check the validation, to check, collect some data for the data interpretation. So in this, for this present exercise, we made some plots in the forest. Like everybody, is a plot inventory is a normal practice in the forest. And then we flown the drone, and we used both RGB, that means red, green, blue. That is a normal camera. So, and also we used infrared camera as well. And we flown the drone at 100 meters altitude with a speed of 4 meters per second. So that means the flight speed is 4 meters per second. And the photos were taken every 2 seconds intervals with a 75% of the overlapping of the images. So that is, you have to see when you fly the drone, you have to have an overlapping so that you don't have parallax error. So if you look at the results, yes, to compare between the first one, pan-shot Plidas is the satellite data, then the drone data is the second heading. So the satellite data, the French satellite data, what we used was 50 centimeters resolution. So the drone data, what we used was delivered 2.8 centimeters resolution. Definitely, it is an advantage for me to use the drone data for separating, for identifying the features and the classification of that object on the ground. Coming to the spectral resolution is nothing but usually they were the spectral bands, blue band, green band, red band, near infrared band, and so on. So when you take the satellite data, the wavelength is separated into specific wavelength bands, and then they can give you different bands information. But unfortunately, since we used RGB camera, that's a normal camera, we have a wavelength of set of wavelength, but we don't have the wavelength separated into different bands. That's one of the limitations of the drones. Coming to the radiometric data, it is we call it in the bits normally. So the satellite data has more bits than the drone data. However, bits are not really that much matters for us for the forest unless you are working in the areas with a big hill shade. shady places. If you have an impact of shades, yes, the higher bit information is more useful for you. But usually we don't have that problem, shadies. So that's why we can overcome that problem by taking 8-digit data itself. Then finally, the temporal resolution. How frequent you can get the data. For example, if you look at the French satellite data, which we use, every 24 hours is the revisit time. That means every day data. For example, if you want a Mizoram data, every day you can get the data sets. You just place an order, that's it. Whether it is a cloud free or cloud not cloud free is a different story again. But you would be able to place an order once just one day before. You can order a picture for it. Same goes with the drone. You can fly the drone every day. It is also same. But only thing is the weather. You cannot fly the drone in the rain or storm conditions. That is the limitation. Especially the drones with the research purpose. We don't have the waterproof drones yet. Coming to the efficiency, how much cost it is really giving the images. For example, we use the drone and we bought the drone and we conducted 2 weeks of field work. And out of 2 weeks, and the amount of money we spent for the drone is 2,400 US dollars was the expenditure we spent. Out of 2,400, and in 2 weeks, we were able to produce only 1.81 square kilometers of the area. We took the photographs. But when you order the satellite data, you get a single image of 100 square kilometers just for 2,300 US dollars. That means the drone data, what you get for 1 square kilometer is highly expensive. But, but you have used the drone only for 2 weeks. Every drone technically is stable. You can use it at least for 500 flights. And your battery in the drone, if it can sustain for 15 minutes, you would be able to come up to 50 square kilometers. Nowadays, the batteries are giving up to 20 minutes. If that is the case, you are coming up to 75 square kilometers. So if you fully use the drone for 500 flights, then the cost of production for that 175 square kilometers is coming down. If you're lucky enough, you can go beyond 75 square kilometers, and that would be much cheaper again. But what suggest is like you have to use the drone for some set of time. It's not one-time use instrument. One-time use is always expensive. So over the period of usage, you will get the products for cheaper cost. So this is various drones with the different models and different prices. You would be able to choose the drones as per your targeted task, research tasks. Coming to the acquisition time and how much big the data. For example, satellite data of 100 square kilometers. As I said, you can order every day, once in every daily is available. And the data, the file of the data is 12 MB, just 12 MB. But the drone data, which we got it for 0.12 square kilometers, was 2,800 MB, too big. Since the data is so big, the number of hours we spent on the satellite drone data analysis was more. For example, we spent almost 90 hours just to process the data set obtained from the drone. Whereas for the satellite data, you would be able to finish the exercise in 14 hours. However, there is one process called segmentation that would be able to bring down the size of the drone image to 194 MB that can further fasten the analysis, which can bring down the time of your time spent on image analysis. So when you look at the different land use, land cover classes, satellite data, due to the resolution, which is just 50 centimeters, we were able to find only the dominant vegetation or dominant land covers. But the drone would be able to reveal very fine, very small features also on the ground. That means even the non-dominant characters you can see from the drone, not from the satellite data. So by looking at by taking advantage of both dominant and non-dominant features on the ground. We run so many classification scenarios, and then we come up with 93 maps finally. And out of 93 maps, I show you some that has been classified based on the object-based and pixel-based classifications. Somehow, in the object-based classification, we use different algorithms. Even pixel-based classifications, we use different algorithms. Some algorithms perform better than the other. So overall, what we found was like pixel-based classification has a more consistent results and having a higher overall accuracy than the object-based classification in the piece of our work. Okay, so far you understood that the drones, yes, can be used. The drone data or satellite data can be used for the classification of the forest. Not only that, you can retrieve the biophysical properties of the vegetation. Biophysical properties such as tree height. Yes, you can find the tree height by just using some model. Here, I am going to show you the example, which we did recently, a canopy height model that is derived from the digital surface model and digital terrain models. So, for example, this particular exercise, we did it on the west coast of Peninsular Malaysia, which is about 7 hours away from here. There was a very big forest there, and the forest, the beauty of that particular forest is from last 100 years, the people are producing charcoal out of that forest in a sustainable way. It is going to be another 1 more hour talk if I give you about that sustainable forest management on the west coast, but maybe next time we will look at it. But we purposefully went to that particular place to see the vegetation which has been undisturbed for almost 90 years, and the vegetation that has been disturbed and planted with some species and 15 years old. So when we look at the we applied the satellite data and drone data, we applied canopy height model, and then we also made some ground truth measurements. That means we measured the height from the ground. What we observed was like there is a close resemblance between the satellite drone data derived tree height and the ground measured tree height, especially in the case of disturbed forest. Disturbed forest in a sense, people have planted the forest and it has a homogeneous nature, whereas the undisturbed forest has heterogeneous nature. So the homogeneous forest is giving the better results than the heterogeneous forest. That's one of the significant findings that can be, you may use it for the research and then see how different you learn. And also that varies with the different crown diameters and the height of the trees and so on. So there are so many approaches you would be able to reevaluate such kind of things. Then we also applied the same logic to find the biomass, because nowadays we are talking about the global warming and sea level rise and so on. So the carbon sequestration, the wetlands, they are really carbon sequestering capacity of the wetlands is much higher than the rainforest, normal rainforest. For example, 40% higher in the case of mangroves when you compare with the terrestrial vegetations. So such kind of importance. And the plants only, not only the plants, they absorb the carbon, but also the soil. It is a rich blue carbon. So that means it is one of the best mitigating measures to fight against the global warming. So that's why we have to conserve the wetlands. So since very important, then we try to extrapolate these techniques by looking at the height we derive from the canopy height model, and then try to derive from the allometric equations to see the biomass of that particular way. Also same here, we found the homogeneous nature of the vegetation giving a closer results than the heterogeneous vegetation for the drone data. So when you look at it, when you look at takeaway message, takeaway home takeaway message. The drone, no doubt, the drones are offering promising results to distinguish different vegetation species. Either it is mangrove or non-mangrove, it doesn't matter. It would be providing a very good resolution that would help you to come up with a very clear-cut separation of the species and their distribution. And also, you would be able to find cryptic ecological degradation. I hope you must be knowing the concept of cryptic ecological degradation. That means from the outside, you see the forest at the same extent. That means there is no decrease. The forest is increasing. But on the other side, you are losing the diversity inside. Yes, that is possible. That's what we call it as cryptic ecological degradation. And that's why the drone can reveal such kind of things very, very precisely. And also tree top and the branch die off diseases, so on. And the people who are working very close to the water boundaries, probably you have a problem of sun gleam. So that's where you have to plan for certain times to take your pictures without having sun gleam. Especially, for example, the mangroves will be inundated by the water. So such kind of times, how it is going to be difficult to the pictures may not be useful because of the glare. So such kind of things you have to plan in advance before you go on with the drone mapping. As I said, the drone is a one-time investment. It's a long run. You can have the images for low cost, no doubt, as cheap as the satellite data. But you have to spend some good amount of time, and you have to have a passion for that science to apply. So, but it is for sure to give you the best results. And also, most importantly, when you use the drone, you're almost likely to get the real-time monitoring. For example, I'm sitting in the office, but I can see 100 meters, 200 meters away what is happening. Without going there, I can see in my screen by flying the drone at that distance. So it is a real-time monitoring, especially in the forest, illegal felling, where there is encroachers, logging. So such kind of things are quite dealt with the advantage of the drone. And I should accept that the area being examined for the present study, which is just 12 hectares for you to present today, but it is good enough to show the potential of the drones over the satellite data. So you can think of it. But as I mentioned, some of them, the drone data has a limitation of parallax error, especially the boundaries. That's where we go for overlapping images. And also the weather without rain and storm risks is mandatory. And also nowadays the birds are attacking. So for example, kites, sometimes they attack, even they are attacking the flights. So they're attacking the drones as well. But fortunately, I don't have that incident so far. But you have to keep on. That's why you are advised to fly the drone within the range of your eyesight. Don't keep the drone away 500 meters and you don't see where it is. It is unable to retrieve them back. You lose it finally. So you always fly the drone at the eyesight level so that you can control. Still, you have a controlling ability to bring back and land at your place. And another thing, when you are flying the drone, is because of ethical implications and security reasons, you really have to look at the regulations to fly the drone. Every country has their own regulations. For example, here I cannot fly within 25 kilometers radius of the airport and so on. So such kind of things are differs from country to country. So you have to look for it. And for Malaysia, we have to report our drones to the civil aviation authorities so that we will get a permission from them. It's the same thing, I believe, for Indian users as well. Otherwise, you will be caught. Yes. Hope I didn't make you bored. I still have some time to speed up. I just, as a final presentation, I would like to share some information on the mobile apps, which are available for free download, and then you can use it in the forest very easily, comfortably. Okay, here in this picture, what you are seeing, one of my students, he's writing the data, collecting the data in the forest, but he's using the right pen and paper, and suddenly it started raining. Then somehow he's lucky enough to find an icebox lid as a garbage there. Then he put the icebox lid as an umbrella, and then he started writing the data. What if there is a digital platform there for us to directly input, key in the data directly there itself? That would be an advantage, isn't it? Yes, here you go. Yeah, he's what you see on the top right corner, Professor Richard Lucas. He's my research partner from UK, from Aberystwyth University. We are working together on mangroves and other ecosystems. They have come up with an app called EarthTrack. It is not necessarily from the mangroves. It is also meant for the other vegetation types. You just they call it as open data kit, where you can to support the real-time data collections and the field-based measurements. Whatever you measure, you can just key in the data, and that data will be useful for global level land cover change patterns and change detection. For example, once you went to the EarthTrack website with the Aberystwyth University, after after signing the land license agreement, then you would be able to download a ODK blank form where you can fill in the details of yourself, your institute, and what type of vegetation you are working on, and what type of how tall the trees are, what is the understory, what is the phenological conditions, and so on. You can data key in. And finally, when you have an access, internet access, you can submit. Once you submit, that will be automatically projected into the Earth observation system as a point, which you can see on the right side. And the data is available in different formats, like a shapefile. Those who are working on GIS, they can use it directly, that information, for the mapping purpose. And maybe you're working in India, but your partner in Belgium wants to see the data. You can download. You don't have to send him an email or file attachment. You can just simply download the data. And the purpose of this kind of platform is to enhance the international linkages, which is a crucial place, very important for all of us as a teamwork. I was able to sustain. I still remember those days I spent with Professor Samthirav sir and my during my PhD days in Andhra University. But we don't know the future. But once the international linkages they introduced to us, and the way we maintain them really brought you to a safer place where nobody can touch you. So international collaboration plays a strong role, and definitely this kind of usage, platform usage, certainly help you to share your data and bring some international collaborations from other partners elsewhere. Indeed, we offer such kind of training to the forestry department people in Malaysia also. So that means people are tending to use the open data kit at the track to report some things, and then it is definitely going to be useful for everyone. To then you can come up with the spontaneous land use, land cover changes. If you observe a change, then immediately you can observe the latitude, longitude, and submit the report. That will be automatically updated. The second app, which is really important for the forest inventory researchers, is gap light analysis. That means how much light, sunlight is entering, reaching the bottom, underneath the forest understory. Light is very important factor for the growth of the trees, vegetation, and survival of the animals. So how much light is really penetrating through the canopies and reaching the bottom. So such kind of analysis, you just make it just by using a mobile app. You can guess it. So it is available for Google Play. You can download it and start applying. Once you download it, you just have to calibrate that particular app, and then go to the field and take the photographs of the canopy. About 9 pictures were suggested. Then incorporate the value at one level, that correction value, and then ultimately you come up with the final canopy cover estimate. So simple, so simple. Earlier, we used to look at the bare eye and we used to estimate roughly, which is not 100% accurate. But here, this is more accurate than any other methods. So you may think of them. And canopy cover, as I said, estimations are very crucial for the understanding the nutrient dynamics and natural recruitment. That means once the seed that fall onto the ground, how it is growing. Sometimes the shade tolerant plants can grow better. The shade intolerant plants, they will disappear. So such kind of logics you can understand by looking at the canopy cover. And once you download EarthTrack and Gamma, actually they could be linked, but now we are coming up with EarthTrack Pro, which will be released in a couple of months soon. And that has a direct linkage that then you don't have to really feed in the data separately. So once you are working on EarthTrack, definitely Gamma is inside, included. Especially the Gamma like app is extremely useful for the forest inventories and researchers for their visual canopy assessments, particularly the forest inventors, either mangroves or non-mangroves. So now you may think of taking a drone with you before you go to the fieldwork and install EarthTrack and install Gamma. And in the field, you just fly the drone and collect the land use land cover data and take canopy pictures and share your data with the international partners. Definitely that can put you in a right place, that can help you to come up with several scientific projects in the future, and also that can help you to come up with the joint publications, which is very important for our academicians. Thank you very much. Thanks for this opportunity, Mizoram University, and thank you one and all. I now welcome questions if I can answer any. Thank you. Voice is not. Yes, yes. Now I can.
It's
Hello.
good.
Okay.
It is very good presentation, Satcham.
Thank you, sir. Thank you, sir.
Can you identify the type of plants and type of forest with the help of drone also?
Exactly, sir. Exactly, sir. Yes, we can. We can.
The kind of diversity of plants also, can you identify?
Yes. Yes, sir. Yes, sir. This is especially useful because we are getting 2 to 3 meters resolution. You can 2 centimeters resolution. You can alter the resolution with the flight. If you take the flight to the higher altitude, the resolution becomes low. If you fly the drone slightly below 100 meters and so on, you get a very clear resolution. Each and every 2 centimeters
How you know the height of the forest from the remote place?
We actually, you have to be there in the at least at some representative places to measure. There are certain equipments on the ground you can use. For example, clinometer. If you use a clinometer, you can find the height of the trees. So the tree, for example, if I go to mangroves, I can see 30 meters height, 35 meters height. So I fly the drone at 80 meters.
Being located in staying in laboratory, can we send the drone to a faraway place without idea about the height of the forest? Can you identify what is the height of the forest?
It is difficult, sir. We always suggest a drone operator to use the drone and fly the drone within the range of your eyesight so that you can control. Otherwise, you lose the equipment. But once you are successfully,
is it possible? Is it possible to collaborate with the satellite image and drone?
Yes.
Satellite image, you will be knowing the height of the forest. So
yes.
after knowing the satellite image of the drone forest, you can send the drone to that particular area.
Yes, yes, you can.
That may be one.
Yeah, exactly. I was saying that straight away is not advisable. But when you have some sort of information, either from the ground by yourself or through the satellite data, yes, that is possible. You can operate. But wherever you go, better you operate the drone within the range of your eyesight, so that you can really control. because the drones, sometimes we suddenly lose the connection. Then the drone goes away and we miss the drones. We already missed 2 drones now. So that's why we don't really
So
go
drone
beyond.
operator, how much distance you can send the
Uh,
drone?
we are using up to 200 meters, sir.
Up to?
200 meters,
Okay.
200 meters radius.
Okay.
So I go with 150, but people are going but that also depends on the drone type. The drone
Yes,
which
yes.
I'm having, DJI Phantom, I'm using up to 200 meters, sir, and altitude until 100 meters.
Yes.
Yeah.
Okay, Lalfak, you can go ahead.
Okay, okay, sure.
Thank you, sir. Thank you, sir.
Okay, now we'll go to the question and answer session. So
Okay.
now let me invite Dr. YT Singh to conduct this question and answer. So please, Dr. YT Singh.
Thank you very much. Many of the participants have given a very good, informative, and you know, they really liked. Many of them have said that, and in the one of them have also said that excellent presentation with all the technical informations, and also some of them likes your email ID so they can contact with you later on.
Yes, no problem. No problem.
Apart from that, we have few questions in Q&A section, and the first question is it goes: is it possible the mangrove pollen grains are useful for extraction / identify the crude oil?
Yes, actually, pollen research is always it's not really in the limelight nowadays, because we have a tie-up with some petrol organization. Here in Malaysia, we have Petronas Institute. Petronas is one of the biggest companies in Malaysia producing petrol. So we used 2 conditions to see if there is any indications. One is pollen, and also the foraminifera. The organisms, microscopic organisms. The foraminifera has given a very good indication for the sea level changes and the indication of crude. But pollen supposed to give a good indication, but we fail to get a very straight away that answer actually. But it has a relation. That's what I heard about it.
Great. And the second question is from Bizendra Jyotis. It says, what technologies can use to reduce wildfire?
Oh, wildfire. Yes. Wildfire is really a big, severe problem that's causing. Actually, I mean, uh, in terms of wildfire, we don't really come across wildfires, but in the mangroves, but in the natural forest, yes. Because of the drought weather, yes, there is a possibility. uh, uh, if I look at it, even the human errors is also there. For example, some of the forests, they although there are signboards not to discard the smoke and cigarettes and so on, but the people are doing it, and that's causing a big devastation and destruction there in that place. So in addition to that, probably wetlands have that kind of problem, less problem, but still they have a problem of thunderstorms. For example, when it is raining heavily and when there is a thunderstorm, you have the mortality of deaths of the trees where the place struck by the thunderstorm. Um, to me, uh, uh, actually, it is in mangroves, in mangrove vegetation. Definitely, it is automatically comes under control in the sense we have a regular inundation by the tides. But in the natural rainforest, unless there is a rain, it is very difficult to control. But probably the human error part has to be minimized. To me, that is also playing a strong role for the expansion of the forest fires. Actually, the natural fires more than the natural causes. So the forest fires through the human interventions should be minimized. If I'm correct, that's my view, sir. That's my view, personal opinion.
Absolutely. Another question is, can we estimate total forest biomass,
Sorry,
or
sir?
can we estimate total forest biomass or individual tree biomass, comma, carbon stock, etc.?
We can come up with the total forest biomass, or we can come up with individual as well. Because when we go to the field, for example, me myself, when I go to the field, we measure the height of the trees and diameter, and we put that particular value into the allometric equation that has been already derived for the mangrove vegetation to derive the vegetation, to derive the biomass of that particular tree. So when we have such kind of data, group data, it is possible you would be able to derive it from a particular patch. Because if you go for single tree, probably that is not an ideal task. You have to go for a representative patch of forest stand. Maybe not that big, but it is like 1 hectare or 2 hectares. That would give you the better result than
Correct.
when you go for individual measurements. Individual measurements always carry the noise.
And some of them want to know about the price of the drone.
Actually, yeah.
Ballpark.
Yeah, now drones are quite cheap as well as quite expensive,
Right.
because the cheaper one drones, even you can assemble by yourself at home. You can assemble by buying the spare parts, and you can assemble it by yourself. It is possible. But the medium range, I would say the medium range, the drone is reasonably good, and I'm using it for my research purpose. That is costing up to $2,000. $2,000. But that is also, again, the price varies when you look at the camera. If you
Right.
go for a normal camera, normal RGB camera, it is cheaper. If I want infrared camera, definitely that add cost. In some drones, you can change the cameras. For example, you fly one time and you take the picture with the RGB camera and bring it down, and you change the camera, fix the IR camera, that means infrared camera, and fly again. But it is 2 times effort. You have to spend some time again. And you are not sure the same conditions prevail in the next 5 minutes. So better we have to have a camera that can capture multiple bands. So when you increase the number of bands, definitely the cost of drone increases.
Right.
So multispectral cameras are quite expensive. So that can go for 4,000, 5,000. But as I said, that depends on the task, research task, which you're really focusing on, how it is going to benefit you. For example, for me, just normal RGB camera is good enough. Just to derive the tree height is good enough. Even to derive the biomass is good enough for me. And even to derive the species classification, good enough for me. I don't want some other extra channels. But for example, some people wants to do biomass through NDVI. That means there is a one step in remote sensing we call as normal differential vegetation index. There is some indices are available. So for that, you need some couple of bands, extra bands like infrared. And so then you can able to identify the health of the vegetation. For example, when your forest is completely facing the drought conditions because no water, then definitely you would be able to identify that particular condition through the remote sensing data set by
Right.
looking at the different band informations. So that is the advantage we have. So to have multispectral, it is a bit expensive. So we have to put a bit more money there.
Correct. To substantiate that, just for my curiosity, you have compared the remote sensing data as well as aerial data using drones.
Yes.
And considering all the course and everything, what do you suggest for a beginner, for example, because somebody wants to know that? For a beginner, what do you suggest? You go for aerial, you go for remote sensing data, which you have highlighted quite a bit, and some of them are freely available also, and some of them are paid. Considering all
First,
the course and everything, as a beginner, what do you suggest, sir?
actually, I don't think the beginner can go for a very big areas, to be frank. Probably I assume that he's going to start his research in a very small area. maybe it's electronic expert. So if it is the small area, because the selection of the satellite data is also depends on your area of selection. For example, my area is small, I need a good resolution data. If my area is big, for example, I am looking at the chlorophyll distribution in the ocean, I just need kilometers resolution. I don't need centimeters resolution. Just kilometers resolution is good enough. Similarly, the area of investigation is very much important. So if he is a beginner and he is going for a small area of investigation, area of interest, definitely he can go for higher resolution data, for example, which is not available for free, for sure. And you have to come up with a drone or air photos if they are already available, taken by the land survey departments, if I'm correct. In India, they might have some old satellite data, but in the recent old aerial photographs, but aerial photographs always delivers a better resolution than the satellite data.
Correct.
So they can go for drones which are less expensive. Since you are saying he's a beginner definitely come up with so many mistakes. So it is also, we have to look into the cost of the equipment investment. So we have to go with the low to medium range of drones, and they can fly, get the data, and then he would be able to compare the data set with any other satellite data.
Thank you, sir. That's all we have in the Q&A, and thank you for the excellent talk, sir. Can I
My
pass it on
pleasure,
to
sir.
Dr. Alfred Zoala now?
My pleasure, sir. My pleasure. It's so nice talking to you.
Okay, thank you so much, Dr. Wati Singh. So now we come to end part of our today webinar seminar. So before I propose the vote of thanks, so if the Honorable Vice Chancellor, if you want to say something, then let me invite him. Then after that, let me propose a vote of thanks. Then that after that we'll close today's program. So, sir, if you want to say something before I close the program.
It's okay, no problem. Go ahead.
Okay. Thank you, sir. Okay, so thank you so much, Dr. Behra, sir. So today you are selecting a very, very challenging and relevant topic for us. So in the future, we may need your expertise, and we may need collaboration with you as a Mizoram University, as well as a Department of Botany. So we are concerned about all these trees, the forest and those things. So we may need your expertise in the future. So thank you so much, sir. Then secondly, I would like to propose my vote of thanks to our Honorable Vice Chancellor for organizing such a wonderful webinar seminar. And this is, I think this webinar series is more than 100 now. So because of his work hard, our Vice Chancellor, so we are having good numbers of webinar seminars so far. And I would also like to thank all the participants. Our participants are not only from India, even some are from abroad. So because of your participant, we are we can conduct successfully our today's webinar seminar. And last but not the least, our technical staff from ICT, Mizoram University, for your support, we can conduct this webinar successfully. So thank you so much, all of you. Thank you.
Thank you. The last word from me. Thank you, sir. Thank you, our beloved Vice Chancellor, Professor Samsivara, sir.
Thank you.
And thank you, sir. Thank you, all
Thank you.
technical staff, and thank you, concerned professors, and for your kind encouragement. And thank you so much for listening to me. And sorry if
Thank
I
you.
make you bored, but my doors are always open. And Professor Samsivara, sir, is a visiting professor to UMT, so my doors are open. And definitely we talk more on coming up with possible collaborations to benefit the botany department. Though I'm not a botanist, but definitely I would be able to contribute some of the technological part. And I can even link you to the Flemish Institute of Technological Research, who is the prominent members in Belgium, flying the drones, commercial. Everything is commercial on basis and something, so that you can have a rapport with so many organizations to benefit the department and the research.
Great.
So thank you so much, and have
Thank
a
you.
good day, everybody.
Thank you.
Thank you so much. Bye.